Hello everyone, topic is the operation and maintenance of high voltage switchgear. Through this lesson study, the goal is for you to master the operational principles of high voltage switchgear and fault phenomena, possess the ability to analyze causes of high voltage switchgear faults, the ability to make judgments, and operational capabilities, cultivate good professional ethics and teamwork skills, and develop a strong safety awareness. The key and difficult points of this lesson are the operational principles of high voltage switchgear and the analysis of fault phenomena. Last lesson, we learned about the structure of high voltage switchgear. This lesson requires knowing which principles must be adhered to during the operation of high voltage switchgear first. Only when the earthing switch is open and the circuit breaker is in the open position can the truck or carriage be moved from the test position to the service position, whereas when the earthing switch is closed, the truck cannot be moved from the test position to the service position. Let's watch a video together to see how the truck is moved from the test position to the service position. Hello everyone, I'll demonstrate our chassis truck moving from the test position in a dynamic process. We can now see the truck is currently in the test position now. We will move it to the service position. Everyone, please watch this process. Our Ferrari truck, small truck, has now arrived at the service position. Second, only when the truck is in the test position or withdrawn position can the earthing switch be operated. Third, the circuit breaker can only be closed when the truck is in the test position. Let's understand the reason through a video. As you can see now, our sliding truck is in the test position. Then we perform a closing operation on the circuit breaker afterwards. This part of the mechanical arm is horizontal. If we do not open it, you can see that as this transmission shaft rotates, the protrusion below will catch this mechanical arm, preventing it from moving. Therefore, our sliding truck cannot be racked in or out. First, when the earthing switch is in the open position, the switch gear's lower door and rear door cannot be opened, preventing accidental access to live compartments. Fifth, when the circuit breaker truck is in the test or service position, and there is no control voltage, it can only be manually opened, not closed. Sixth, when the truck is in the test or service position, but there is no control voltage, the circuit breaker can only be manually opened, not closed. Seventh, when the truck is in the service position, the secondary plug should be locked and cannot be removed. Now, let's watch a video. From the video, we can see that if operations are not performed according to regulations, operational faults like those in the video will occur, posing a threat to both personnel and equipment. Therefore, students must have a strong awareness of standardized operation and operate according to the operational principles. Otherwise, switchgear accidents or faults may occur. Next, let's look together at the common faults of high-voltage switchgear. The first type is circuit breaker failure to operate, refusal, or misoperation. This is the most critical fault in high-voltage switchgear. Its causes can be divided into two categories. One category is caused by mechanical faults in the operating mechanism and transmission system. Specific manifestations include mechanism jamming, component deformation, displacement or damage, loose or jammed opening, closing iron cores, loose shaft pins, trip failure, etc. The other category is caused by electrical, control, and auxiliary circuit issues. Malsations include poor contact of secondary plugs, loose terminals, wiring errors, burnout of opening, closing coils due to mechanism jamming or faulty transfer switches, failure of auxiliary switches to operate properly, as well as faults in the operating power supply, closing contactor, micro switches, etc. The picture shows the secondary panel of a vacuum circuit breaker first. Check if the secondary circuit board has any problems. Then check the auxiliary contacts and energy storage contacts and whether the secondary plugs have any issues. The second common type of fault is breaking and closing failure. This type of fault is caused by the circuit breaker itself. For low oil content circuit breakers, it mainly manifests as oil spraying, short circuits, arc extinguishing, chamber burr, insufficient braking capacity, explosion during closing, etc. Oil circuit breakers are relatively more hazardous nowadays. Most power plants and substations use vacuum circuit breakers more frequently. For vacuum circuit breakers, it manifests as leakage in the arc extinction chamber and bellows, reduced vacuum level, rest strike with carburetor banks, ceramic tube rupture, etc. The third common fault is insulation failure. Insulation level refers to correctly handling the various voltages applied to insulation equipment, including operating voltage and various over voltage. The relationship between various voltage limiting measures and insulation strength. The aim is to make the product both safe and economical, achieving optimal economic benefits. Faults related to insulation mainly manifest as external insulation flashover and breakdown to earth, dissolution insulation flashover and breakdown to earth, face-to-face, insulation flashover and breakdown, lightning over voltage flashover and breakdown of porcelain bushings, capacitive bushings, flashover, pollution, flashover, breakdown, explosion, etc. Another common fault is current carrying failure. The occurrence of current carrying failure is mainly due to poor contact of the switchgear isolation plugs, leading to contact melting. Therefore, the clamping force and tightness of the plugs and contacts are very important. During selection and inspection, a careful and rigorous work attitude must be maintained, with no room for negligence. The last type of fault involves external forces and other faults, including accidental impact, natural disasters, short circuits caused by small animals, etc. The occurrence of other unknown external forces and accidental faults is something we cannot predict, but we must take precautions against them. This lesson mainly covered the operational principles of high-voltage switchgear and the phenomena of faults that occur. Please use your spare time to think about the following questions and complete the after-class tasks. That is all the content for this lesson. Thank you for listening.